wire itself. And then to hear that that's not it at all. And then, but then everything else, you know, if you think about it, like what we were talking about, shielded wires, they shield them. And because there's a purpose for that, because if you think about it, if all the electrons were all running right through the wire itself, you wouldn't need a shield. So because the EMF, that whole field is set up around the wire, then that's why it has to be shielded to eliminate any interference with anything else. So that makes sense.
But you know, they're also saying that it could be a transformer, right? But I thought transformers only worked with AC, right? With an alternating.
That's right. So, they won't work with DC.
So it couldn't really be a transformer.
Well, now they will. And there's if you take DC like on a vibrator and you chop it up, which it ends up being an alternating current of some kind, you know.
It's just
that's the purpose for having the vibrator, so that you can take DC voltage in a car, and then by using that vibrator, you're chopping that up and turning it into, it's not really a sine wave, but it's the same principle. So therefore, then you can transfer that through the transformer and then turn it into high voltage B plus. That's the whole purpose of it. But straight regular DC will not go through a transformer.
Yeah, it's the collapsing and building up of the magnetic field that actually makes the transformer work, right? That's how I know.
Yeah, and the sine wave, it's collapsing and building back up, and then therefore it will transfer onto the secondary.
So that really tells you it doesn't have to go to the negative part, or the negative, wherever you put the, you know, the negative part of it, like on an AC line where it goes positive. You know, a vibrator. Hi, Mark. We're talking about what you brought up. You stirred a can of worms last week.
Wasn't a can of worms.
You're muted, Mark.
You brought up a good subject, I thought.
It was a great subject, but boy, they sure have a lot of videos on YouTube now about that subject. You're still muted. There you go.
Now, there you go. You're talking about that. I'm still trying to figure it out myself.
Yeah.
Have you seen the rebuttal videos?
I've seen some of those things, you know, and I'm going like, okay, you know, and maybe the idea about the power transmit furrow, but there's different ones, you know, and it's like, it's still head scratching regardless.
Yeah.
Yeah. Well, the whole thing is theoretical anyway, right? I mean, you could never have a 3 million meter long wire.
Oh, yeah, sure. But as one of the guys mentioned, that if you put it in a circle, then it would be a different outcome.
Yeah.
Wrap it around the
oil. Yeah, it would be a different outcome.
But still, when you hear the part about the electrons are barely moving, creeping through the wire, that's you know, see, there's some strange magic still going on there.
Well, look at like the different kinds of interferences you get in your house with your RF on, like for instance, like an AM radio. If you get it near fluorescent or a lot of the ones that are bad are the new LED lights, the amount of electromagnetic field that comes off of those things can cause all kinds of interference with your RF signal in your radio. And then the one that's a real killer is get an AM radio and then have a rheostat that controls a light in your house, and have that turned on to the same circuit. And I'm telling you what, it'll just really mess with your radio bad.
But
yeah,
most of the electronic devices you're talking about, though, are actually transmitting energy on, because they're not designed. Unfortunately, the FCC never really enforced their jurisdiction, their power or whatever, and keeping things quiet. They just let it go. So we're just, you know,
so I mean, what happens on those guys? You know, back in the old days, a dimmer would have an SCR on it, and the rise time would be really slow. because those SCRs were crap and they were using, really big geometries, but now they're using these high frequency SCRs and triacs. And so what happens is when you turn the thing on in the middle of the 60 hertz cycle, the frequency, the overtones of when you turn that thing on, the rise time is so high that you get harmonics, well past AM.
Oh, yeah.
That's
Oh,
right.
sure, because that's what a
Sure.
square wave is all the odd harmonics, and the square it is, the more higher
Yeah,
it is.
so
higher
the
it
rise,
goes.
the rise time is so ridiculous, and
Yeah.
Mhm.
with the modern devices, and they don't
Yeah.
put any inductance in there to try to cut it down or
Well,
anything.
and they're also trying to do the efficiency part of not having the device have any or any dissipation during between on and off, and so
Yeah,
yikes.
because if you put an inductor in there, you've got to pay the price for that.
Yeah.
Yeah.
Hey, Bill, is that a shower radio you got there on the wall?
So are we doing test equipment tonight or?
Yes, it
Yeah.
is.
Oh, yeah, there, Bill. I see.
You don't have one of the clap on, clap off ones.
That's true. Don't need one.
I worked with a guy who was the designer of one of those in the 70s.
Oh, the clap on, clap off?
Yeah,
Oh,
yeah,
really?
yeah. About 75 or 78, something like that.
That was really successful, wasn't it? I mean, it was huge.
Yeah. He was a designer for a guy who was sold that stuff and retailed it.
Worked for Ronco, huh?
Yeah, he was like,
Ronco, yeah.
yeah. So it wasn't his full-time job, but he was one of the designers of that thing.
It's great. Had to been some kind of audio switch of some type. I don't know. You know how it worked, Myron, or?
No, I mean, it was just an audio amplifier with some kind of thresholding,
Yeah.
But the trick was to make it run off of AC and, make it cheap.
Well, yeah, or it had a relay or something in there that would control the AC circuit.
Yeah,
I don't
so
know.
it wasn't,
Yeah, I'm guessing.
it wasn't a processor and it wasn't a relay. They just had little, SCRs or something,
Okay.
triacs or whatever. And so, it's a pretty simple analog circuit, but trick is to make them robust and cheap, right?
Yeah.
So how's the weather there today?
The weather
Beautiful.
was great today.
Oh, is it 60 degrees, wasn't it? I think something like that.
Yeah,
was
it was 60, something like that. And in the afternoon, we actually had blue sky. So it was.
Oh, yeah, it was.
It was
Beautiful
I got some
sunset.
blue now, but we had rain this morning. But I was up on the slopes of Mauna Loa at 8,000. It was 50 and raining. This feels just like where I'm used to. But I was wearing shorts though, and
I was watching a documentary. It was Edge of the Universe the other night. Come on and on Netflix, and then it showed those two telescopes up there in Mauna Loa, and what these guys were doing.
yeah.
They were trying to find evidence of planets in stars that were several light years off, out of the solar system and in different star systems in our galaxy, and then. They were doing it they were checking to see the gravity causing the star to wobble. And then with these gigantic telescopes, and they were actually making it so that the two of them were combined so they would get a better sight picture on this thing to see. And then they were able to determine that these stars had planets going around them. It was a pretty good show. It was real interesting. But they showed the road that you take to go all the way up, to the top of that, where those telescopes are. And then that's really fantastic because you're so high up. It's just like you're you're in an airplane or something, you're just so high up, you can look down on the
Yeah.
ocean and the rest of the island, you know, it's pretty cool.
Yeah.
Are they gonna build the next one? I mean, have you been talking about that?
That's still up in the air. But
Okay.
but their alternate site, La Palma, is now erupting, and I just kind
Oh.
of laughing.
That kind of puts a wrench in that plans, doesn't it?
Yeah, because they were trying to say that that site was just a smidge less desirable than Mauna Kea, and that they could just go there instead. And actually, there's now resistance. I don't know why there's, well, I know why there is here, but I don't know about in La Palma. But but there's clearly going to be a big much more atmospheric distortion from the 8,000 to almost 14,000. Surely there's a very significant difference in that. They tried to say one time in an article it wasn't that much different, but I kind of doubt that.
Yeah, I would too.
Yeah.
And there's that one in Chile that
It's
is up in those Andes mountains, and it's way
19,000,
the
I think,
heck
or
up there.
something. Yeah. But the thing is that can't see the part of the sky that Mauna Kea can see, and vice versa.
Right,
See,
right.
that's so you need one in different hemispheres to see all the stars, and
Sure.
because you'll see, you know, and well, it's some of the native Hawaiians are saying that's sacred up there on top of the mountain, and it's been desecrated, and all this other stuff, and you know, typical, you know, you always have that no matter who it is or where it is. So I don't know. I'd like to see, maybe they need to manage it better than they have. And they are going to decommission some of the smaller ones when they put that one in. So it's not like it's
Yeah.
going to be a bigger footprint. But there's all kinds of stories like, oh, they're going to have a nuclear reactor underneath it to power it, and they're going to go into the water table. They have to cool it, and all these other bizarre things that people put out there. It's crazy.
Yeah.
So I tell you, the biggest blight is the camp they put it down at the highway, where they set up a protest to block the road, and all these tarps and tents and stuff, and I can't imagine the sanitary stuff going on there. So it's just I think it's a power thing partly. You know, we can stop this, and we can get something for it. And the thing is that there's a lot of money and lands set aside, but then they haven't been distributed. And I think there's a lot of corruption in that system. And I think that the money is that was set aside is probably not there. Yeah.
Yeah, I've heard that one before.
Yeah, so I think that they're probably being aided by the upper part of that's trying to keep things going, so they can get some more money coming in, so they won't discover how much that they've wasted of it.
Yeah.
Yeah, it's the same old story.
Same story.
Yeah, I it's something that I didn't realize when I moved over here. You know, I never thought it'd be like going into Louisiana.
Yeah.
For the corruption. And it's until our former mayor here, they finally he got charged for 130,000 of inappropriate spending on his government credit card, and 29K of it was personal stuff, which he did pay back, but the other stuff is like for whining and who knows what. But I mean, it's just like, I'm going, what? I think that heads would have rolled way before over in the mainland for the most part, So it's like,
yeah. Well, our former governor and his girlfriend, they were involved in a lot of bad stuff too.
Oh yeah, I remember that. Yeah.
Hey, Mark, would you do it again?
Would I do it again? Yeah, I still like it. It's I'm just saying I just didn't really realize,
Sure.
Yeah. When I say light rail Portland, they were just better at bearing all the corruption and the overrun costs. Here in Honolulu, they still don't have the light rail built, and they're I don't know how many billions still away from finishing it, and they're how many billions over the budget. It's just insanity. And they'd be smarter to stop building it, but then there's all those monuments that would be up in the air that they built for it. It's just like
I know a few, I know a few
That's
people.
funny.
it's lunacy, but that's what they did. And actually, Honolulu to me is one of the most ideal place for the light rail system, because they have traffic that goes along the freeways back and forth, and it chokes it every day. It seems like a natural, like that's a great place for it. And here they just blew it.
I know a few people that when they retired, moved over to different places in Hawaii.
Yeah.
And after a couple of years decided to move back.
Yeah.
I
Well,
know.
I don't get I mean, actually, this is the big island, and it's the size of, larger than the size of the Portland metropolitan area there. So as far as, physically, square miles, 4,000 square miles. So I don't feel like I'm confined anywhere. And the weather's nice, it's real comfortable. I mean, like I say, I was just up in the mountain at 8,000 in shorts. I mean, it was cooler up there, but it's always comfortable and stuff like that. And it's pretty, and the Northwest is pretty too, but
How about the hobby? Do you find a lot of people over there to share your hobby with?
I mean, and antique radios, not as much, but there are some collectors, but there's no club per se, like we have here. Hams, plenty of hams. I mean, I'm an amateur radio operator, and plenty of activity that way. So as far as collecting, no, it's not so good.
How about if you were to go to Honolulu, actually, would you find it there?
More so, yeah. There's because I mean, Honolulu's I mean, Oahu is about 800,000-900,000 permanent residents there, so that's
Yeah.
pretty good sized city and the island population. Here, there's just a couple 100,000 on the big island, and a much greater,
I think what you have to look at too, as far as collecting, or how many radios were actually over there, is not the population that you have now, but what was the population
well, and
in
actually
the 30s and the 40s when people had those old radios.
Yeah, but I think the radios would be more so here because TV used to only come out of Honolulu, and that's a long haul here. I think radio would have been more relied on. And I found a Philco 70 up north on the north end of the island. I looked at. I didn't really want it. They're kind of big, and I kind of keep things, kind of smaller. And then surprisingly, stuff probably comes over from the mainland too.
Sure.
There was a 9.2 Walton on Craigslist one time, and of course they wanted eBay prices.
Yeah.
Or dream prices, and I have no idea the story in that one. But that I've and then I know of I did see on Craigslist. I was tempted because it was a 12-tube GE console, and one that had the turret tuning, the slide rule where I mean, kind of the cool. To me, that's kind of cool, but
Yeah.
I resisted that temptation. I don't have a place to put it, so. But
Well, I imagine you're probably right. I mean, in Oahu, of course, you had the military over there, and then when it was like, what was it? It was early 41.
Yeah.
They moved the fleet over before Pearl Harbor, but they moved it from San Diego over to Pearl Harbor, just before the Japanese bombed. And so you had that whole military going on there, and then you had all of those sailors and soldiers and all those guys, and they're probably bringing radios over from the mainland, and stuff like that.
There is a little store up on, so above us here in town. There's the upper old highway at, and there's an old store there, and it's like almost like a time capsule. People own it now.
Oh,
It's not
wow.
the family that had it. They sold it and they bought this thing, and there's and I've talked to them about it because they kind of had the store like a museum, and they kind of closed that off. I let them know that if they ever decided to just sell there was one radio. It's in the office. There's an old safe, and it's a Philco 66, I think. It's one of the little bit smaller ones that from the later 30s, and that's original equipment from the office. They sold radios there at the store, and
Oh, cool.
I just let them know if they ever decided to sell the stuff, I'd find a home. It could be a home for that. So
Sure.
because they closed down the store itself. They're still, I think they're producing coffee there or something else. But just a second here, I'll go get the sign.
Cool. Well, I'll let Mark bring that back, show everybody, and then I brought one of my favorite pieces of test equipment, and this is a Tenma 72505 audio generator. I don't know if you can see that, and here's the leads that go to it. Yeah, go ahead, Mark.
I just real quick there. If you can, they get that lined up right.
Oh, that's nice.
That if they had several ad posters, and so they made them up, copies of them.
Oh, cool.
Yeah.
Hey,
Yes,
Mark, during
sorry,
those
what?
years of the World War II, did they have AM broadcast?
Oh yeah.
Okay.
The lady that had the Philco 70, I think she said something about hearing something about the attack or something, because that's back in that time frame, or that it was her, maybe it was her like her mom or somebody like that talked to remembrances of hearing about the attack on the radio or something like that, because we're a couple hundred miles away there almost.
Well, they actually, the Japanese, they triangulated that and they listened to that Hawaiian station coming out of Honolulu.
Yeah, that'd be right. Yeah,
So that
probably
they could track, and they use that to actually help guide them into Pearl Harbor.
Yeah.
During the attack.
Yeah, they probably it's probably KGU or I'm trying to think some of the stations that most of the old call signs aren't there anymore, but
yeah. Anyway, but I was going to say I started to show you this thing. This is one of my favorites because it's real handy. It's small, and it runs from 20 up to 1.5K audio signal, and so it starts out real low, and as you turn this thing up, I should have brought a radio to demonstrate, but as you turn this thing up, it goes higher and higher and higher tone, and it's really neat if you have lost signal in your radio, because you can hook this up in any stage or any grid. It's best to hook it onto the grids, and just ground the one side and then hook the red one onto your grid, and then it'll produce an audio tone through the radio, and you can find where you're losing signal that way. I start out the speaker and work back until you found the place where you've lost signal. And then I'll usually use that between that and then an oscilloscope, going the other direction if need be. And then see where your RF signal is coming in on an oscilloscope, and then work your way, and then you're going to find and nail down right where you're losing your audio signal in the radio. But it's a very handy device, and there were several members of our club that had given this to me for my birthday one year.
So Mike,
it's kind of cool.
what's the signal on that? How big is the signal on that? Is it
It's-
microvolts or?
Oh, yeah, I believe so, Dave. It has an amplitude adjustment here, and it ranges from frequency ranges, and you can do it on hertz. You can do it times 1 or times 100, and then this has a separate waveform. There's a waveform switch here to go, and I just usually normally keep it on a sine wave.
Mhm.
And then it's 0 to 20 dB. And then this has it just, I usually just leave these two on out, but it also has a place where you can hook up to sync it if you want to sync that, I believe, with like a signal generator or whatever. But it's just handy to use all by itself. And
So,
but it
so you
runs-
don't, you don't oversaturate the, like if you go into the RF section, you don't like just blow it out of the water by putting way too much signal into it on the grid then, huh?
No, no, because it's not that powerful. It's not, it doesn't, it's not going to overpower anything like that. And then usually, and normally, you'll get a good tone, like if you come from the volume control or onto the grid of the detector, that type of thing, then you can get a good tone through if the radio's working good.
Does that,
And
does
it'll
that
even
stop
do
it?
that. You can even hook it up right to the output transformer of a speaker and get a tone through that way.
Yeah, but it
It's not as
doesn't,
loud because it's not being amplified. But
it doesn't, oh,
it's a
I-
nice little handy unit to use. I mean, you do the same thing with most signal generators if you just go on to an audio signal only.
Mhm.
But this is just handier to use. You just got 2 leads, and then you hook it up to the radio, and then you keep tracking back until you lose a signal and find out where your problem is. So anyway, that's one of my favorite little pieces of test equipment.
but you're not going into RF though, are you? You mean it stops at a high audio,
You
right?
can, because you can take an audio signal and put it back, clear back even onto an RF amplifier tube on the grid or a converter, and Mark, and it'll still produce an audio signal through the radio.
You're
Alright.
you're just not discriminate. You don't have the discriminator really working. If you put you don't have the carrier wave on it. So it's,
No, you don't. It doesn't
Right.
have a carrier wave on it. It's just strictly audio, but it'll still send a signal through.
it should.
But I myself personally on that, I like to either hook up a signal generator that's modulated, or sometimes just tune the radio in, because if the front end's working and you have a problem elsewhere, then you can go on to like the converter or the IF stages, and with an oscilloscope, and then you can usually see the audio signal being modulated around the RF with the RF carrier together. And then that'll tell you right there if your front end's functioning too. So kind of in conjunction with an oscilloscope is how I like to use it. And use the oscilloscope more on the front end, because it gives you a better idea if you have an RF signal and with the audio impressed on it. So, but you can take it all the way back and you'll still get an audio signal out the other end.
And who makes it then?
The name of the company is Tenma, TENMA. It's a number 72-505 audio generator. And it looks like that.
702-505
audio generator. And it says Pioneer Boulevard, Springboro, Ohio. Believe it or not, but I believe this thing's probably made overseas, I would guess.
Sure it is.
But it doesn't say where, it doesn't say China on it, so. Anyway, just a real handy little unit to use when you're running some diagnostics on a radio that doesn't play, that type of thing.
Well, and the fact that it's battery operated, you don't have to worry about the return path through the ground.
No, and then, that's exactly right, Mark. Yeah.
72-505.
Yes. There's a hashtag in front of that, Dave. It says hashtag 72-505 audio. I imagine that means number 72-505 audio generator is what's
Yeah,
on it.
I found it.
Okay, cool.
Yeah.
Anyway, so that's what I have.
So when you use that, you started the speaker. You said you started the speaker and then go back and then go to
Yeah,
that,
that's
the
usually
power
what I'll do. Yeah. Yeah. Just start at the speaker.
and your
then
speaker,
go-
you'll hear a hum, and then you know that's not the speaker, and then you go back.
Yeah. Yeah. You
Farther.
get a tone and then go back to the output tube. Usually you want to put it on the grid there. Don't get mixed up with the plate voltage, you know. It's not good for it. If you probably could put a capacitor on the positive lead and be okay and put it there if you wanted. That prevent any high voltage DC if you wanted to do that. But it's not necessary, you know, unless you suspect it's a problem with a tube. But I don't use it for that. I just usually always hook it up on the grid, and then go to the grid of the detector and the volume control, and then IF amplifier and on back. So yeah, till you find where you don't have a tone anymore.
And then you just lose a tone, then you know that component's
That's a stage where you've lost your signal path. Yeah.
cool.
So
So it shows
simple
that,
to
like,
use.
opens a lot. I mean, is that where you find it? In it? Like an open something? Is that
Oh,
what you
I
usually
was working on one here the other day. It was a TRF. It was a Jackson Bell. It was a 5 tube. It had 3 RF amplifiers. They were all 24As. This thing was made like about 1930. And it was AC though. It had an 80 and all that, you know, and it had a power supply. And I was getting nothing out of the radio at all. And so I did that. I hooked that up, and then it went back to the detector tube, and that area was getting nothing. And come to find out, then from there, I hooked the oscilloscope up. I kind of did it in a roundabout way. I probably just should have started checking voltages first, but I didn't. And I'm getting a good signal out of the RF and up to that point. And you can see that the voice, you know, coming was modulating the amplitude of the signal. It was, you know, hey, the radio should be playing. It's not. So then I start checking voltage. I didn't have any plate voltage on the detector. And the reason why, there's a real fine wire coil in that radio that was coming off the B plus, and it was kind of a dropping resistor. And why they used that wire wound resistor, I don't know, but they did. And it was open right there, but it was luckily it was right on the end. I just took one coil off of that wire where it was broken, took and cleaned it up, you know, take some sandpaper and got the enamel off of it. It was like number 34 wire. It was real fine. And they were putting about 100 volts on the plate of the detector, which was a 24A. And boom, she just took off and played. That's what it was. But
It feels good when that happens, Mike.
I couldn't see it was broken, but as soon as I started checking it out, I found out that's where it was open, and it was right on the feeding the B plus to the plate of the detector, and that was that drop-in resistor. And so yeah, stuff like that you find, you know.
cool. Thanks, Mike.
And nail it down. I took one winding off of that, didn't hurt it a bit. You know, the radio didn't know the difference on that, and took off and played great. Had open-end, single-ended 45, and then it had 3, what was it? 3 or no, it was 6 tube. That's right. It had 4 24As, a 45 and an 80. Nice little radio. And I'm working on one now. Is a Philco Model 14, and it's got push-pull 42s on it, which is, and then it has a, they're on an interstage, they're being driven by an interstage transformer, and the driver is actually a 42 as well. And all three of those tubes, they tied the, Philco like to do this. They tie the plate and the screen together and then make those pentodes into triodes. So you can run a push-pull setup off of it, because there's nowhere to feed when you got it in push-pull. You know, there's nowhere to feed any separate voltage onto the screen. So they just tie the two of them together, and they work great that way. And it just turns a pentode into a triode. And so they use 42s instead of having to use 45s. Probably because Philco had jillions of them. I have no idea why they did, but they did that a lot. You'll find a lot of Philcos that are push-pull, and they use 42s, and they use them as triodes.
Which is actually underserving the tube, right? I mean, underusing the tube.
What's
right?
that?
You'd be underusing the tube for its capability, right? But
Well, kind of, yeah, in a way, but yet when you do that, and especially using it in push-pull, it gets, you know, tremendously good audio. You know, they work really well.
sounds good. Anybody else have test equipment they want to show?
I do, not my,
You kind of broke up, Dave.
I said I do, but I'm just coming back to my desk right now. I got, I went out the garage to get my test equipment. Let me go and show you what I have.
Oh, good.
Okay, I'll show you my favorite thing initially. And you all go, yeah, right, Dave. That's interesting. But let's go up here. I gotta figure out how to start my video. There we go. All right, this is my favorite piece of test equipment, the Fluke 189.
Oh, nice. Yeah.
And you know, it's old, it's dirty, but I use it for everything. You know, from checking the batteries, you know, like the garbage can lid doesn't open, and you go, well, I think probably one battery's bad, so you go and check them. Yep, one battery's bad. And you replace that, and it works again. Number one tool I use, and that's of everything I own. I use this more than anything else I own. Number
What
two
model
tool.
Which model is that one?
It's
Dave?
a 189. It's
189.
it's a mid-range Fluke, you know, but
Yeah.
I use it on my bench because everything is isolated, it's floating, you know. This is my number two, and this is pretty cool. This is a DRD, so it's DREEE, and it's a, I can't remember the name of it, DE 5000. And what this is an LCR meter, but it's actually a 4-wire meter. So they did come with 4 wires, but what I did is I put some Kelvin probes on it.
Yeah.
And so this is actually crazy accurate, crazy device. I mean, this is one of those things where another one of those things, like probably 30 years ago, this probably would have been a $20,000 instrument.
Wow.
You know, it's just crazy. Measures inductance. So like if you want to know what the Henry of your
really?
whatever is, it measures capacitance. It measures resistance. So like for capacitance, you can put a signal. I think it goes from 100 hertz, 120 hertz, like for your electrolytic capacitors. Do like I think it's 100 kilohertz, or is it maybe it's a megahertz, you know, signal for you know, your tantalum capacitors and things like that.
Oh, okay.
So you can measure them at frequency. And same thing with inductors, and it's just a wonderful piece. And it's $100, right? So it's
Nice.
one of those things where, well, I had to buy these, and that's another $10. But this is one of those I think cool tools that just wasn't available 20 years ago. And then the third thing is, I'm sorry.
I'm sorry, Dave, so you can check inductance on that, like on a
Oh, yeah.
output transformer,
Yep.
that type of thing, so you can you can use that for and matching that type of thing. Wow, cool.
It'll measure your capacitance and inductance. You know, so yeah, so like if you're fixing a coil or something like that, you can measure the, you know, at different steps of frequency. I think it's, well, let me turn it on. Okay, it goes, let's see, frequency. It does 100 hertz, 120 hertz, 1 kilohertz, 10 kilohertz, and 100 kilohertz. So it measures at different frequencies. So you can actually like measure like capacitances and inductances at frequencies.
Oh, nice.
Yeah. So I like it. It's really nice.
So what do you use it most on? Like capacitance, like ES?
Yeah, you know, if I got something kind of fussy, I'm trying to go like a sort out a capacitor, like a 0.100, you know, microfarads. You know, you can do it, right?
Right, with DSR.
Yeah. So DEREE LCR meter. It's a DE 5000.
Very nice.
They're on what eBay all over the place.
Yeah.
And then this one I took apart. So what I built is I built a calibration tube for a tube tester. And so this one has got the ability to measure, it's got 1,500, 3,000, and 6,000 micromos calibration tube. And it uses a, what is it? Oh, I can't remember the chip. I've got the schematic, but essentially I built this to go inside of a old ballast tube shell.
Ballast tube. Yeah, that's what I was thinking that was. Yeah.
You know, and you know, it's got like the little, you know, where the switch comes out and stuff like that.
Sure.
And then I have it so it can also load up the filament. So I have a I think a 10 ohm 100 watt resistor that will also load the filaments. So I use this when I calibrate my tube testers. So like on a TV2 tube tester, it there's a shunt resistor in there that is a, you know, kind of like the TV7, except for this one is always in place. It's just a slightly different design.
Yeah.
And what you can do is you can go and set that shunt so that you measure GM directly off the meter. Now it may be like it may be like, yeah, kind of like the 752A, where you might have to multiply times 4 or 10 or some number.
Mm-hmm.
But you could go and do direct measurements of GM off the 752, and that's kind of nice because that tester, you can adjust all of the. As a matter of fact, I can go get one if you want. You can measure the screen. You know, you can measure. You know, you can set the screen voltage, the plate voltage, the bias, and also your signal voltage, as well as I'm thinking, you know, filament voltage, of course. But you know, you can set all those to pretty much what you have in the tube manual. So what you can do is say this should be 4,100 micromos or whatever, and then, you know, at 250 volts plate and 230 volts screen, and you know, with a bias of 12 or something like that. And you can actually set that up, and you can actually compare directly to like you know, get a better idea. It's not perfect, but you get a much better idea because to what how your tube is relative to the published data. And it's pretty reasonable, you know, because your signal's, you know, down to a 1/4 volt and some of the scales and stuff like that. So you're not like overdriving your small signal tubes, you know, like a 12AU7 and things like that.
So you can set that up. I take it, and then when you are calibrating that, you're checking that against what the meter shows when you go ahead and like on a TV7, when you go ahead and set it, you know, turn it on. or push the button for conductance, mutual conductance, and then it'll show what the micromole shows on the meter, and then you want to calibrate that to what your instrument shows. Is that correct?
Yeah, exactly. Mhm.
Nice.
And well, like I use it primarily for my TV2 because
Yeah.
like I say, it's a linear system, so you can just measure, you can turn your pot until
Right.
I want to have it so 0 to 150 is equal to 0 to 3,000 micromoles. So you just turn your pot until you get 6,000 lines right up, or 3,000 just lines right up, 1,500 lines right up. It's done. And then you just write it down on a piece of paper. If I want to measure direct GM on the TV2, I can just set it at 37 or whatever, and
Right.
multiply it times whatever 10 or whatever, 20 or 100 or whatever, the
It
value
is. Yeah. Yeah.
So anyways,
That's a neat tool. That's a neat setup, Dave. That's pretty cool.
yeah. So, but yeah, the TV, the problem with it is that, the TV7 is, I don't know enough. I actually got one. So, but it's,
Yeah, I
out
have
of-
one too. I use it that's my tube tester. I use it every day.
mine's out of calibration, right?
Uh-huh.
So I have to calibrate it. It's functional, but it's out of calibration. So, one of the things about it is that the screen voltage, I think, is 130 volts, or should be. And then the plate voltage is 150 volts, or it should be. And the plate is a pulsating DC that you put your signal on top. And the signal,
Okay.
I think the signal only goes down to a 0.5 volt on the A setting, and I think it's at 5 volts, which is too high of signal voltage for like your small signal tubes. So the problem is that when you look at your mutual conductance curve, where you have, like, if this is plate current versus bias, you have curves that look like this.
Right. Right. Yeah.
And what happens is that because of the, no, it's this for different bias levels. This is plate current versus, I don't know, what the plate voltage. And then you have your different biases. It goes like that. And anyways, what happens is that you're not in a linear range of this curve,
Mhm.
right? So you can't necessarily say that the tube value at 250 volts or whatever it is in your test manual, your tube manual,
Right.
that change is the same as, at 150 volts. It could be a different slope. So that's a transconductance is a slope. And
Sure.
so the values between a TV7 and a TV2 may not match up. That's why you have
Oh.
0 to 150 it's a quality score that they
Mhm.
just measure at that particular point.
Yeah. Yeah.
But it's not really probably relevant to say what the transconductance is unless you run it at the operating point that they publish in the tube manual.
Mhm.
Or you can look at the curves in the tube manual and say,
Well, yeah, you can always do that, but
it's-
you
Yeah,
got
'cause
to, each particular tube, has a certain plate voltage that's set on, and then you check that when you check mutual conductance, because it also has a set bias that you feed into it as well.
Mhm.
And so it's just like you said, yeah, it's gotta be right in that curve, depending on what bias voltage you're sending it. It should have the proper amount of conductance to the plate, and that's what you're checking,
But
And,
yeah, exactly, Mike, and it's got to have the right, how you set your tube up. It's got to have the right voltage difference between the
Mhm.
plate and the cathode. The
Yes.
bias is got to
Right,
be
right.
aligned like that and stuff like that. And so,
Yeah, I know.
You need a curve tracer.
Yes.
man, I tell you what, I got kids. I'm willing to give my kids up, for
He's
that one
right.
of those.
Yeah, with a curve tracer, you can see it in all these different operating conditions kind of in one shot, just about,
Oh yeah.
but that's kind of cumbersome too. when you're trying to test tubes, you know, if you really want to look at GM.
Yeah.
The problem with the older curve tracers is how do you get the data off them?
Sure.
You know, because you have to take a picture, right? And then you got to go and count the reticules and shit like that, you know, and, which is a pain in the butt. They had that was it what was that guy in Denmark's name or Holland? He's not Denmark. So what is it? The Mute Tracer?
Oh, yeah.
You know, that seems kind of interesting. Or there's a guy in Korea. I think he's Korean. That
The thing
does a
about the
heat
curve
tracer.
tracer, you know, you can dynamically change biasing and plate voltage and screen voltage and you know, on the fly.
yeah.
Watch how it does things. How does it feel, you know?
Oh, absolutely. Well, they got those electronic ones. What I was saying, the Mute
Yeah.
Tracer is a digital one. It's
Mhm.
it's based upon a pulsed, as opposed to like, so it has a capacitor for the plate and it just pulses it. But it's like a millisecond time frame.
Uh-huh.
And but that should be essentially infinity, right? I mean, for a tube, it runs in the megahertz or gigahertz, but it's not exactly how they did it when they built the tubes because they didn't have that capability. So who knows what obscure change would make this tube behave differently with a pulsed operation like that. But,
How often do you actually use a tube checker?
oh God, never. But I'm just kind of fascinated. It's more of an,
Really?
you know, I really don't, I'm not doing this shit for you know, I'm not into just repair of radios. I'm kind of into the whole learning thing. If it's interesting to me, I'll just go off into the weeds and,
Okay,
you
that
know.
makes sense. Because I find that tube checkers for many years, their best purpose was to sell tubes.
Or there's some valid uses for them. I think
They've got,
you know, I think that's a good way to check for shorts at voltage.
Yeah.
You know, that you can't do with your DVM. You know, things happen. You know, you get electron migration at higher voltages that you wouldn't see that at low voltages. Things like that.
yeah, most of the time I find that it's easier and more accurate to identify a problem with the tube just by measuring it in circuit.
Well, no, it's got to work in circuit, but you can't screw up a circuit by putting a bad tube in it.
That's right. That's right. That's why I always use one all the time. And I think the biggest thing is like what you said is just check to make sure on shorts. Last night I was working on this Model 14 Philco and I plugged the 42 in there and it was shorted on every dial as I went around with this thing. I mean, something was badly shorted, and that's where, you know, you don't want to run plate voltage, for instance, on your cathode circuit or something like that, because you can really screw things up and in the radio. So and then, you know, I got a TV7, so I check the mutual conductance on it, you know, and everything, make sure it's in a range where the tube will work. But that is a big scary thing. If you have one that's really shorted bad and then you put it into the radio, you can have you can let the smoke
Disaster.
out.
That's what I like about the you know, like I got that TV7 or not, the 752A. I bought one of those, right? It wasn't working. I fixed it. That's what I like about that is that you can measure the resistance, the short, actually as a resistance value, as opposed to just a little neon light coming on, right? That's 375K
okay.
or something.
Okay.
So those are nice too. I think
I just repaired a radio for a guy and it's an AC/DC. And anyway, I thought all was fine and gave it back to him and he comes back, well, it's gone. Hiss, click, hiss, click, hiss, click. What? Yeah, after it warms up. Well, it turns out he's got a higher line voltage there. Well, I tested those tubes in my Hickok and they're fine. Anyway, so I got it back and So I tested it at low line, it worked fine, put it high line, his click.
Oh, wow.
So I ended up putting the output tube in the Hickok, and I jacked the heater voltage up just a little bit, and the damn thing shorted out.
I'll be damned.
Really?
Of course, you got that fine little filament in there
Huh?
on those AC/DC tubes.
Was it a 50L6?
No. 3. It's AC battery.
So you
Oh,
know
battery. Oh, okay.
you know what I do,
Oh,
Bruce?
I see. AC battery. Oh, okay. I thought you meant All-American 5.
3V4.
Yeah, it's something like that.
3V, yeah,
nature.
3V4, yeah, right. Okay.
And of course, it just pull the B plus down to nothing. I mean, then
Yeah,
it pop back up. And
that was your hiss and your click.
yeah,
So Bruce, you know what I do when I test tubes like for shorts? I take a pencil and I tap the
Yeah.
side of the tube. Did you do that? And
and I didn't see a thing, not until
there you
I
go.
jacked up the heater a little, he had high line over there, which just loosened that, got hotter. So
Expands out.
it expands out a little.
Mhm.
Well, one of the things I like to do on those sets is put a 9-volt Zener over the filaments, so you don't run
Yep.
into that.
Yep. Yeah, well, you got to give it headroom.
Yeah, but they got, a 2000 ohm resistor off of the AC line and a rectifier. So
Yeah. Yeah, I had put Zeners in there, but I didn't put 9-volt in
Where do you put the Zeners in?
across the heater supply.
yeah, so they're dropping, like 120 or whatever volts through a 2100 ohm resistor, and there's a diode in there too, as sometimes a selenium or whatever.
Yeah.
And that's relying on the fact that the line voltage isn't that high. So if you put a Zener across that drop
just going
after
to
the
ground?
dropping resistor to the across the filament, basically the series filaments, then that keeps that thing from going more than 9 volts. And 8.4 isn't too bad actually.
So Myron, let me ask you this: Is it
That's what I
so for that
Zener,
all American 5? It's each one of the tubes are 1.5 volt. Then is that what it
No,
is? Or
we're talking about a portable set. So,
Yeah.
it has 5 1.5 volt tubes, and one of them is a 3-volt tube. So there's 6 times 1.5. So it's a 9-volt filament string. And
I
it runs
see.
off of either a 9-volt battery. Sometimes they parallel them up when they come off the batteries. So that's, a 1.5 volt battery or something. But anyway, it's a 9-volt filament string off the AC line. And they've got like typically a 2100 ohm resistor after the selenium rectifier and some capacitors and stuff.
You
But
basically have 90 volts B plus typically, and you drop a resistor from that down to the heater voltage or the filament voltage.
yeah, and there's typically
Right.
2100 ohms is what you see there, or 2000 ohms kind of things. And so, it's you're strictly at the mercy of the line voltage.
Yep.
And so a 9-volt Zener fits in there real nice, and it's not going to have any real problems in terms of power dissipation because you've got that 2100 ohm resistor taking care of all that, right? So
I see.
you want 50 milliamps through the tubes typically. And
The other thing is if you've got an open heater, then all that voltage goes into the 10-volt filter cap. It tries to
that's
pull it up
true.
to 90 volts.
that's true. It will do that.
Yeah,
Yeah.
because you
I have a
usually have a
tool
couple
tester.
hundred mics on the filament string.
So yeah, you don't have to worry about the B plus so much because if it goes to 95 volts or even 100 volts, the tubes don't care. But the filaments, can be a problem.
So Bruce, are you saying when the filament opens up, that's when you has to start replacing all the capacitors then too?
No, there's you've got a 9-volt heater string, and typically they put a 15-20 volt electrolytic across that to keep the hum out of the heaters or the filaments. And so if you have an open filament, then that heater string voltage will try to go up to 90 volts where the resistor is pulling it up because you don't have any load. So that's going to put a lot of extra voltage across that filter capacitor, which will probably take it out.
That's how I was asking. Yeah.
Yeah.
Yeah, remembering these are, you know, as Bruce says, these are, you know, filaments. These are DC. They don't have any heaters. They're directly heated, just
Right,
like
they're
the old
directly,
tubes from the
yeah.
old days, from the 20s, right?
No
So they
cathodes.
turn on immediately. When you turn on one of these sets, you don't have to wait for it to warm up because it's ready to go.
Yeah. I
Interesting.
had a night tube tester that faked me out. It was like one of my first tube testers I ever had. It was it was just a simple emissions tester, but it worked good, and I used it quite a bit. And then, so I was working on an AC/DC radio, All American 5, and I plugged a 35Z5 into it and checked it. It checked out real nice and everything, and it came up well and all that. And so I got done with the radio and I turned it on and nothing. And I'm going, what is wrong? You know, I discovered I didn't have any filament voltage. You know, I had an open somewhere in one of the tubes. So I start checking them, and I check them and put them in the tube tester and all of that stuff. And then they all checked out good again. So this time I took the ohm meter and went across all the leads, and come to find out the rectifier tube, the 35Z5,
Got a
that
tap.
thing was open. It was open between pins 2 and 3. Okay. But the tube tester was checking it between 7 and 3 and not 2. And then it would light it up and it would say it was good.
Oh,
And yet
interesting.
the filament was open between 2 and 3. And so the only way I found that out was with an ohm meter finally. And I discovered the dang rectifier tube is no good. But you put it in the tube tester and it said it was good.
Yeah, it's got a tap filament for the pilot lamp.
Pilot light.
Yeah, it's a pilot lamp, you know, and whoever designed the tube tester, they were using that to feed to complete the circuit to just from 3 to 7, which was the lead just for the pilot lamp. Why they didn't set it up so you had to go from 7 to 2, I don't know.
Yeah.
But it just faked me out of my socks, and I couldn't figure out what was going on there for a while.
So Mike, let me ask you this.
Yeah.
You turn a knob, so it says heater 1 and heater 2. You could have gone from 2 to 7 on your, just by changing the knobs, right?
That one there, I'm trying to remember because that was a one, and it was an emissions tester too. But
You only had a couple knobs.
you only have a couple knobs. Yeah.
Well, yeah, but
I
you
don't
got the
think it
little
gave
levers
me
that you can
the
go to ground, or
ability-
you can go to. No.
That unit there, I don't think it gave me the ability to do that. But I don't know. It could have, but I just set it up the way it said in the manual too.
Sure.
You know,
What voltage would you put on the
but
center
you might
tap
be
if you
right.
were going
Maybe
to test
if
it from
you did, I
there?
don't know.
What
don't know
voltage
now.
would
I
you put on the
sold it.
center
It's a
tap
good
if
tube
you wanted to?
tester. And I got a TV7 now, and then I have another one that's an emission tester I use for a backup, or it's kind of a portable. But
Emission tester gives you quite a bit of info, you know, for the most part.
yeah,
It
Is you,
gives you the shorts and
yeah,
basically the tube's good.
well, is it shorts, or you get electrons off that cathode?
Yeah.
And then that's the two
You,
biggest problems, right?
does your TV2, do you have gas checks on yours too, Dave?
Mhm.
On that? Yeah, I always do that too. I check to see if the tube's gassy.
I don't know if it's really, if that's really testing whether it's gassy or not correctly, though. I mean,
Well, I don't know either, but that's I just read the instructions on how to do it, you know.
Well, it's cathode current, right?
It's grid current.
I'm
It
sorry,
is.
that's what I
It
meant.
is grid
Excuse me.
current.
Yeah, grid current. Yeah.
And they put a
Like I say-
resistor in, and they take a resistor out, and they measure the differences between the, the meter will change.
Yeah, yeah. If the
180
meter-
k or something like that.
if it goes over one value, I think, then it tells you that it's gassy. have found very rarely tubes to be gassy like that. Most of them are pretty good.
If they got getter, you're probably all right.
Yeah.
For the most part.
Yeah, it's got a getter in it. I think
But
so.
no, I've had great emissions show up where the tube had been hit real hard because of the coupling capacitor. So it was drawing lots of current and got really hot. And actually, I think what happened is that actually some of the cathode material got onto the grid. And
Oh,
so
yeah.
the grid was doing some
Emitting.
emission.
Right.
Oh, yeah.
So I've heard it, recommended that, like for 50 L6s and such, that you might want to increase the cathode resistor. They run those things at like 150 ohms or, 130 ohms sometimes you see. And I've heard people say, well, 220 is not so bad to prolong the life of the tubes, right? Because just what you're saying, that you get this, the cathode ends up on the grid and then they start getting leaky. Because I had a lot of trouble with a 50A5 last week. I talked about this maybe 2 weeks ago,
Oh,
Yeah.
where I had a box of like 5 of them, and they would
That's
all
right.
do the same problem, and so apparently they have some kind of a construction problem where if you run them hard, run them hot, then you end up with a bunch of the cathode on the grid, and then they run away when you. I mean, there's 2 ways to run away an output tube. One is, this leakiness where the grid starts drawing current. And the other way, of course, is because you're driving the grid positive because the capacitor coming from the detector is leaking because it's got to go across, 100 volts or something. And I'm sure we see that one more because they all leak, right? But I just never run into this leakiness before.
So Myron, if you put a bigger resistor in there, that means your cathode's gonna be more positive. So your field between your cathode and your plates can be different, right? So do you have to mess with the grid then? I mean,
No, what's going to happen is it's going to pull the operating, the quiescent current through the output tube to a lower value. So instead of running 50 MA when there's no signal, it'll run 40 or 35 MA, when there's 0 signal. And so there's less heat involved in that cathode, right? So you're just not pulling nearly as many electrons across there. And then I was reading this in antique radio forums or something, and the guy said, well, you put a 220 ohm resistor into the cathode, and then you can get all the gain back by bypassing it with, a 30 microfarad, 20 volt capacitor or something. So you can get all the gain back. But, you lose gain by moving the operating condition to a lower current, right? But by doing this, you prolong the life of the tube because the cathode's not nearly as hot.
you lose gain, but I mean, you also lose your
you're gonna lose a little
dynamic
power.
range too, right? Because you have to have a higher grid voltage to shut it off, and because your fields are higher. But you don't have that, so you're not.
Well, you're still running a sine wave in there or whatever, is coming in from the previous stage. And you basically just, you lose gain. And so you can get that back by bypassing the cathode, which typically you don't see in these sets. They don't bypass the cathode. So you have a lot of negative feedback.
You're gonna
from
lose
that,
you're gonna lose some power along the way, though.
Right, you're gonna lose power. Right.
Yeah,
Right.
well,
But if you're
okay,
not
but
needing it, then it doesn't
how come
matter.
you're going to play your AA5 at 5 watts?
Yeah.
Yeah.
Well, the other thing is too, how long do you run these things? You're gonna wear
Well,
the
there's
tubes out?
that. How many decades? Yeah.
Yeah, you're gonna wear the
Well,
tubes out.
What I found, another thing too, is that if you take an All-American 5 and then real simply, and what I've found is if it's running a 35L6 in it, so okay, you got three 12s and a 35 and and 235s. So that's 106 volts. And sometimes they put a dropping resistor in there, because if you're running back when the radio was made, they figured the thing was going to be running at 110, or they would figure it at 117. Well, now we're up to 120, sometimes 121 volts, depending on your house. Just really a real easy solution, is just pull the 35L6 out and put a 50L6 in it. Now you just gain 15 volts in your string, and then you run that 106. Now you're right at exactly 121 volts.
Yeah, we saw a lot of that substitution in the early 50s.
Yeah.
Did
And
that.
they're other than that, other than the heater voltage, they're identical. 35L6 and a 50L6. The only side effect is that it takes a little longer for the radio to warm up. That's it.
Not bad.
Yeah, that's a good substitution.
As you're saying, if they draw the same filament current to the.
Yeah,
Oh yeah, 150
Yep.
mils.
absolutely.
All right.
But I thought the idea of, upping the cathode resistor was not a bad.
So if you're a cathode resistor, what percentage do you want to up that, Myron? Anyhow,
Well,
are you
I
load
was reading
resistor,
that,
right?
220 would be okay. But you see some sets that are like 150, and God forbid, 130 or something. But they always get hot. They're typically half watt resistors run at half watt. And so over the years, they drift up.
Right. Oh yeah.
Because
They'll all drift
they're
up.
underrated massively, right? You
Yeah.
run a half watt resistor at a half watt, that's
Mhm.
that's bad for them. And
So
so,
do you up the wattage on them too, and then also the value?
well, I think
or-
1 watt at 220 is pretty conservative.
Yeah. So you're saying what, 220K? Is that what you mean?
220 ohms, right? We're talking about
220
the cathode.
ohms.
We're talking
Oh, I
about the
see.
cathode, the cathode bias resistor, right?
Cathode bias resistor.
Yeah,
Okay.
yeah.
Load resistor.
So
Right.
that's what
Okay.
pulls it up to get the negative on the grid, right?
Yeah. Yeah.
Yeah. So it's the output, the 50L6 cathode to ground. Typically you see like 150 ohms or something like that.
Oh, okay.
But 220 is a lot more conservative, and you see 150 ohms at half a watt, for God's sakes. And
Yeah.
you compute what's the dissipation? It's like a half a watt. Well, how long do you think that's going to last, right?
Not very long.
I mean, a few decades, right?
So
But-
you put a 220 at 1 watt
yeah,
resistor in there.
yeah. Now you're getting conservative,
Sure.
So I don't know. I was reading antique radio forums about that, because I'd had that problem with the 50A5s. And,
Yeah, you told us about that. You couldn't find a good one.
yeah. So everybody says just swap out the socket and put a 50L6 in it.
That's a lot of work.
Yeah, because you have to drill out the rivets.
Yeah. Well, but you can do it. If it's going to save the radio. If you like the radio, it's a nice one.
Yeah.
I know these guys. I think I mentioned this earlier at another.
He's gone. Mike's gone.
He's dead.
Said, this is easy. He says, they all fail the same way, and the manufacturers over there in China, wherever they're being made, they put like a 2200 microfarad, capacitor in there that's rated at 20 volts, and they put that into a 15 volt circuit, and so you're only got a leeway of 5 volts in that circuit. They says they all fail one time or another, and then or they get old, and then he says he just takes them apart and he just looks for the domed electrolytic. And he said they cut those things right down to the gnat's ass on voltage, because they can buy 30 jillion of them cheaper.
Yeah.
If they're rated at 20 volts instead of 40 volts, which is where it should be. you know, like, you know, what Myron is saying is to be conservative, so it's not gonna fail. But, you know, even at low voltage, a 5-volt leeway is not much, you know, if you get a spike or something and. or
I
it's just
suppose that
weird.
works with transmissions too, doesn't it?
Yeah, yeah, it does. You wanna give it some leeway.
That's what we did with refrigerators. GE refrigerators had a bunch
Yeah.
of these capacitors in them that were bad, and they would just dome the tops of them. So you
They
just
would
go,
dome out, yeah,
yeah, you just
they'd
clip off the
blow.
capacitor with new capacitors, and then it worked great. But
Yeah,
yeah, they had a warning level. It would like flap when the capacitor went bad. The ice door for the the dispenser would
Uh-huh.
flop forth. It would just go bump bump bump. It would just keep flopping until you unplugged it. So these people would go crazy about it. It was like, oh, you knew exactly what it was.
I'll be darned.
I call that a case where the bean counters have won out over the engineers.
Yeah. Well, I
That's
just ran into, somebody just gave me this thing. It's a Caprice. And it's not quite the size of a pack of cigarettes.
Wow.
I don't-
Holy cow.
Well, I can't focus, can I?
Yeah, I can see it, okay.
Anyway,
Looks like
Yeah,
a razor.
Yeah,
volume and tuning.
volume and tuning right there.
And let's see here. 1 AA.
Nice. Wow.
That's a metal case.
I just put, no, it's, well, yeah, I think it's a metal around the side, but it's plastic front and back.
Hmm.
And, you know, it's all speaker, all crammed
Wow.
into this narrow little thing.
No kidding.
And, well, there is a headphone jack
Headphone
along
jack.
with it.
Yeah.
But anyway, I just stuck a battery in it. It doesn't work. Part of the problem is I had to smash the battery to get it in because it doesn't fit.
Well, at least you're using a Kirkland battery, you know, which is probably going to go bad anyway. So.
Yeah, that's right.
Oh,
I-
man.
I thought I'd pretty much gotten rid of all of these, but I do have a few left.
Yeah.
There's
Those
some
are the
kind of an
longest
odd,
batteries, but
there's some
anyway.
kind of an odd sized AA that's shorter than an American AA, and that I've seen in Japan or some places like that. I've had old transistor radios where they wouldn't fit, just like what you're talking about.
Huh.
Well,
And,
this-
and they're shorter. They're
Yeah,
like
they're-
shorter by, you know, a couple of millimeters or something.
This
Wow.
fits lengthwise, but down here at the bottom, there's a post that goes down to the front. And it's too close to the edge and the battery won't slip in
Oh.
here.
Oh, so that's different. Yeah, yeah.
So I had to squeeze the, the side of the battery to,
You just,
to plug
you know,
in.
Probably didn't
Dremel a
do it
little
any
off the
good.
side of it. Yeah.
Yeah,
Hope it didn't short the internal the cell system. The cell.
anyway, it's a pretty cute little
That
job.
is cute.
Yeah,
One of the
The Japanese-
smallest radios I've seen.
Got a little key ring thing here at the top.
Oh, cool.
I'm having a hard time seeing that for some reason. No, I mean, the whole battery, as a whole radio is just, what the hell is it? I'm having a hard time.
What do you
It's
mean?
just, it's got a little volume button. It's got a little tuner on it. And that's just a radio then. It's just a little
yeah, it's
tiny-
the micro.
It is.
AM
Probably
radio.
10 transistors, right?
It's a mini.
It doesn't say.
You didn't count them up, Bruce?
A lot of those ones said were 10, you know, 10.
It's a Caprice. I don't think,
Made in
let's see, let me open it up again. I don't think there's 10 transistors in there.
Oh, probably not.
There's not,
Probably
I'm thinking 2 or 3 maybe.
An interesting set.
Does it say where it's made, Bruce? Does it say Japan on it?
On the back, it is made in Japan.
So that's got to be like
Uh,
60 early 60s.
See that neat, oh, let's see if I can get it.
Up.
It's like, you
Comic?
know, Adam,
Yeah, it's a
Adams kind of
Yeah.
thing.
I'll bet you that's late 60s or early 70s. More
You
like,
think so,
yeah,
Mark?
because just thinking like earlier 60s, the pieces weren't quite so small.
Oh, they made them. They're like standard made. Japan made quite a few
Yeah,
small ones.
they made, yeah,
Like-
Japan made a little 10 transistor one. That's what I was thinking of.
Like standards.
British design regulation number 946611. I don't know what that means. But it does, it says made in China.
Well, they
So-
stole the name,
Japan.
they stole the name from Chevrolet.
It should be Capri, not Caprice, right? It should be Capri.
Well,
So let me
Caprice
ask you
is
this.
that-
So how does the antenna work on that?
A caprice. I don't know. It's got to be a rod antenna, I would
Yeah.
guess.
somewhere in there.
Yeah. Maybe I'll have pictures of it next time opened up.
Cool.
I got too many other things to work on though.
Yeah.
I can find a lot of those 9 volts too. The earlier 9 volts were a lot smaller than the modern 9 volts, and some of those Japanese radios I have, they won't fit in there, it won't close all the way.
Well, I'll be darned.
You mean 9 volts or double A's?
9 volts.
Oh,
Even the-
okay.
Yeah.
Because I've had trouble with double A's too.
Yeah, it's not- not-
The batteries got fatter like everything else.
Well, there was a Japanese standard for double A's that was slightly shorter.
Slightly short, yeah.
And so I was
Well,
able to
the-
use triple A's with an adapter.
tri-
You get these
The
little
AAA is
adapters.
shorter, isn't it?
Yeah, once you can get a triple A with an adapter to double A's, it's like a little capsule that goes over triple A's.
I wonder if they were a
Double
little,
A's.
I wonder if they were a little smaller in diameter. That's what I need.
Well, a
Could have been,
AAA
yeah.
would go in there if you had an extension on it,
Yeah.
because I think they're shorter than a AA.
Yeah, they are.
Yeah. So that one of those would fit in there nicely, but you know, you'd need something to extend the length. That's what
Well-
Myron was talking about.
Just stretch the spring out a little.
Yeah, there you go.
Bruce,
Oh,
Jeff says that IKEA AA batteries are end to end a little bit shorter. Anyway,
Yeah, so much for standards.
Yeah.
well, they're from what, Sweden, I think, right? So, but probably made in China.
IKEA is it's not
No.
Swedish, is it?
Norwegian, Sweden, somewhere over there.
Yeah, it's
Something
all the
like that.
same, right? All
They're
the
very-
Scandinavians.
Sweden, there we go. Jeff says Sweden.
Is it?
Norwegian
Sweden-
communists.
Sweden.
Veden? Svaden?
So, Bruce, what's your favorite test equipment?
Curve tracer.
Curve tracer.
The 5570,
I knew he was gonna say that.
the
Yeah,
55,
that,
right? It costs us
570. It's 570.
Oh, 570.
Yeah, you're cutting me deep, Bruce. That's all I
Yeah,
can
well,
say.
if- I don't have a 570. The museum has it.
Oh, wow. nice.
And we actually had to buy that. It wasn't a strict donation. But that was one of the real cornerstones of some of the technology Tech did. And so the other thing, when you're looking at leakage, well, I did this a little while ago, didn't I? A couple of months ago, where I took a 12AU7, I think it was, and I looked at the current between the heater and the cathode. And there's actually current flowing there, which is not in any documentation I've ever found on vacuum tubes.
Yeah,
At normal voltage, I was getting about 200 microamps. As you raise the heater or the cathode above ground, it just about went straight up and then 200 microamps, no matter how high you put the cathode voltage above the heater. But if you bumped the heater voltage up, that current went way the hell and gone up over 1 milliamp. Let's see, I was doing 12 volts. I don't remember what the next step was on the curve tracer. It might have been maybe 17 or 18 volts. And the current between the heater and the cathode went up to 1 milliamp, 1.2
Wow.
milliamp, something in that order. So when you're running the tubes too high a heater voltage, you've got a lot of cathode leakage current if you've got any voltage on it.
But does that cause hum?
No. It causes DC current. So the heater is acting like a bright emitter. Your very early vacuum tubes were bright emitters. Without the thorium and all that junk they added for better emission characteristics.
Yeah.
And so at low glow, basically there's not a lot of current. You had to crank those up so that they were fairly bright to have much emission at all on those early vacuum tubes.
Well, some of them,
That's basically what you're doing between the heater and the cathode.
but they would put not a pot, but they put rheostats on the heaters of one of the tubes, and that would be their volume control.
Right.
Some of those battery sets.
Mm-hmm. But a lot of those sets, the heaters are, well, the filaments are quite bright.
Right.
They're not the dull orange glow.
Yeah.
They go to overcome the work function, right?
Yeah. And in the case of, well, they're called thermally limited. In the case of the 555 oscilloscope, they regulate the filament voltage because there's so damn many tubes in it. And so what they do, they have a diode which has a filament, not a heater or a cathode, but a filament acting as the cathode. And it's what they call a bright emitter. And so as you change the voltage on that, it changes the current in the diode dramatically with very little change in the voltage on the filament. So basically it's the feedback that goes back to the regulator that regulates the filament voltage to all the vacuum tubes in the display unit.
Well, that's interesting.
It drives a saturable reactor transformer that regulates the heater voltage.
That's a ferroresonant transformer.
No, it's a saturable reactor.
Well, I know what you're talking about there reminds me of like the original 01 tube, not the 01A. The filament current was like 2 amps. It was unbelievable, and these things were just bright like a flashlight, that super bright. And then that's when they got rid of that tungsten or whatever the heck that was. They went to a different material in there, and then they dropped it dramatically down. On the 01A is like, I think it's under a quarter volt or something like that.
Quarter amp.
I mean, that's what I meant to say. Quarter amp, yeah. And so of course that dramatically helped the life of your battery too.
Oh yeah.
So Bruce, does the museum want a 555?
We have one. I don't know if we want another or not.
I still have one.
You still have one? I I can ask.
Myron, where the heck did you find that?
It was at a swap meet in, where was that? The thing they used to do in Puyallup.
Rob? So
Yeah,
you gotta-
Puyallup ham swap meet they used to have up there. I mean, no, maybe they still have it, but
They
that was
still
like,
have it.
yeah, 20 years ago.
So you got a power supply with it and a power cord or the
Yeah.
cord?
Oh, yeah, got it all. Yeah,
Oh, okay.
yeah. It's got the red cable and the power supply. Yeah.
Yeah, a lot of times that they end up missing the power supply or just the cable to connect the power supply to the.
Yeah, it's a
display.
monster. Yeah. But,
Yeah.
How about the cart and the hand truck to move it?
yeah, exactly. Yeah, it's a
Yeah.
monster. Yeah, it's a
Is
beast.
it a megahertz? Can you measure megahertz on it?
I think there were 35 megahertz scopes.
Oh, they were. Wow.
I mean, I don't think they were 50. Bruce can probably tell us. 547s were 50.
Yeah, there were at least 50. I don't recall.
What was the number in the scope?
555. 2 scopes in one.
Mr. Carlson's lab has a few of them. He's
Oh, yeah.
It's 2 entire scopes all driving onto one tube.
One CRT, huh? Yeah.
How many tubes are in there? I mean, there's
Oh God, it's like 120 or something.
like for 100, right?
Cow.
Yeah, I mean, it dims the
Really?
lights when you turn it on.
Heats
And
up
it has
the,
a timer, so it's 60 seconds before it actually turns on the B plus after the filaments, I think.
You know
Oh,
why?
really?
There's a timer relay, so it doesn't strip the cathodes.
Got it. Exactly. That's why they do it.
The TVs did that too, right?
No, I don't think any TVs had a time delay.
It's
Yeah,
some
it
sort of
actually has
delay.
a relay inside of a vacuum tube that's a 50-second delay or whatever.
Oh, really?
Yeah, I
TVs had
fired it up.
Had a, what was that resistor that would, it's a negative coefficient of thermal resistance. So it would be very high resistance when it was cold, and then it would go down when it heated up. And that's how they modified the voltage.
It kind of gives you a slow start.
Yeah.
Keeps the inrush down.
Yeah, thermistor, I think. Right?
Mhm.
About.
Is that called a thermistor?
I believe that's the correct name for it.
Yeah, you can buy different versions of those, for based on the steady state current that you're going for. I forgot what they're called, but there's -30, -50, -80 and stuff like that. The transoceanic guys were into putting that on their transoceanic filament strings.
There, honey, just eat it. Don't apologize. Just
Those are also used a lot on just the main AC power feed for a lot of the old equipment, just to keep from arcing the power switch.
Oh,
I had one let go on a big UPS that when I worked for the state that put the network off the air for a little while.
ooh.
That's when I was sick. They had a thermistor, an inrush, or they call it inrush protector, whatever. And that was the Achilles heel on the UPS because everything went through it. So they didn't think that one out. The UPS that did UPS.
Well, I'm gonna bail out. I have a couple of wires. I had to pull the variable capacitor off that Philco, and I had to put new mounts on it. They were totally shot, and so I'm gonna solder the wires from the capacitor back in. So before the night's over, so I'm gonna go out and do that. So,
next week is novelty radios. So
yeah, novelty radios. I don't think I have any novelty radios.
you have to dig out your sexy Linda.
Yeah. We got Coca-Cola radios. So anyhow, I'm gonna take off and head out to the shop and do that. So everybody have a good night and we'll see you next week. Bye-bye.
I got pizza in the oven, so I'm gonna go too.
Yeah, actually, I'm gonna go night night myself.
Dave, do you want to make any announcements about the party or?
Oh, so I think we're done with taking people who want to yes or no go to the party. We have 49 people, but I still need to have some help for. I'm going to send out emails, but I'm going to need some help for people to help set up, take down. I think we're going to need 2 people to help with the food that people are going to bring to help organize that, and you know, basically the big things is set up and then take down and clean up. So.
And that Abernathy has some utensils there, right?
I bought utensils, Christian. I have, as far as the desserts go, I think that everybody should bring their own serving utensils. Just, I wouldn't trust about how clean those were in Abernathy or whatever. Everybody, I bought heavy duty plastic utensils that are already pre-wrapped in the napkin. So they're not gonna be handled. They're gonna just napkins gonna be placed down on top of the plates. So, but I would recommend bringing your own serving utensils. We'll write that up. You know, we just basically the decision was made tonight that we're done finding new people now, and now it's gonna be the neg. I'm gonna start negging you guys to help sign up to help and certain duties. For instance, we need somebody to make coffee, right? So.
Well, thanks, everybody.
All right.
Yep.
Later.
Bye.
Thanks for asking, Franklin. Have a good night.
You too. Bye.
Bye-bye.